Hello.
Hi.
We're back now. Let us finish this by looking at confidence interval for proportion. The last one we did before we were timed out, we were able to finish it before we were timed out, is for small sample. Now this one is for proportion. And when we talk about proportion, we are referring to the percent. The proportion is a part of a whole. So we call it a percent. We call it proportion when we are doing confidence interval. Now, for us, we have that for that type of confidence interval, we are trying to estimate the population proportion using the sample proportion, which will represent as p hat. Let me make this bigger. P hat. It's called p hat. This is sample proportion. Now, to estimate the sample proportion, if it's not given, we use p hat equals x over n. And we need Q when we are doing the confidence interval. Q hat is always 1 minus p hat. And the error margin, we estimate it using this formula. So in this case, we don't need to start going, well, of course, we still go to the table. We need that because we need the to get the error margin. And after that, we can now use, instead of x bar, we're using p hat plus error, So let's try this using this example here. It says, in a sample of 200, I hope you can see this. Yep, good. In a sample of 200 investment advisors, 70 recommended IT stocks. Give 95% confidence interval for the true proportion. So for this, we have our solution as follows. Okay. First thing is our how many sample is n equals 200 investment advisors. Remember, this is small n because it's a sample. So that was small n. So I think I'm going to move this down so I can, yeah. Then out of which 70 recommended IT stocks. X. Recommended IT stocks, which is 70. So we can get our p hat using the formula x over n. So let's go and get it. I'll take you to the other workbook so that we can quickly calculate it. So our p hat is equal to, I'll make it a little bit bigger. Make it 16, 116. So our p hat equals s over n, and our x is 70, n is 200. And that gives us x over n. You can get this in a calculator. The value of x over n, which is what is the calculator? 70 over 200. So I move this up a little bit. Clear this? 70 divided by 200. But 0.35 p hat, 0.35. So I will go to that section. Our main workbook. I'll copy this and go to put it 0.35. Then I'll copy it. Go to the main workbook and put it in. So have it here. P hat, 0.35. Now Q hat is 1 minus P hat. It's right here. So Q hat is 1 minus P hat. Okay, which is 1 minus 0.35, which you can get from the calculator. 1 minus 0.35. Okay, here it is. 1 minus 0.35. You can see the answer here as 0.65. So Q hat is 0.65. So we'll go back here and put it in. Q hat 0.65. Now we have that. Next is to get our error margin. Error. To get our error, we use this formula here. But we need to find the alpha. It says the question says 95% confidence interval. Now, from previous example that we did last time, I showed you that 95% you can get it from the table, and the critical value as the alpha over 2. I can get it from the table. Okay, I can get it from the table, or my computer is freezing up. Okay, or you can, if it's not in the table, you can estimate it by yourself. So our Z up to, the computer is really acting up today. Z alpha over 2 alpha over 2 equals because it's 95%. Let's see if it's on the table. So if it's on the table, we use it. If it's not, we can just calculate it using the formula that I explained to you in the class. So on the table, we look for the Z alpha over 2 for 95%. So it's gonna be here for 95% right here. That's 1.96. So our Z alpha over 2, 1.96 on the table. So we are lucky it's on the table, so we can just pick it up. Okay. So go back to our workbook. Okay. It's 1.96. Okay. Now, okay. See? Now everything. Now next is to calculate the error. Once we get the error margin, our confidence interval. Formula for error margin here is Z alpha over 2 times square root of P hat times Q hat over N. Then put it on the other workbook. Put our values in and get our answer, and then paste it in the main workbook. Yeah. Oh, excuse me. I think I need to do this. Okay. So let's just look at it. And I'll make it a little bit bigger. This 11 is too small. Yeah, I think you can see that now. So put the numbers in. We have a P hat, which has the alpha over 2 is 1.96. Okay, times the standard deviation, times the square root of, square root of P hat, which is 0.35. 0.35 times Q hat, 0.65 over N. Remember that our N is 200 investment advisors. So we can get this from our table, from our calculator. Write it down. square root of 0.35 and 0.65 over 200. So I'll take it here to the calculator so we can calculate it. Move this up. Clear this. Hope you can see this. Okay, you can see that. I can see that. All right. So we have square root of see 1.96 first of all. 1.96. Okay, times the square root of 0.35, 0.35, okay, times 0.65, okay, over 200. That gives us 0.066. 0.066 as our error margin. So we go to our book and put our error margin, then copy it and paste in our book. Book. Okay, this is our book right here. So we can put our error margin under our problem that we are solving. Okay. Yeah. Now we have our error margin. We have our p hat. We can now calculate compute our confidence interval using this last formula here. P hat minus error equals P. Well, and why do we use P? Because we are calculating the confidence interval per proportion. So the 95% confidence interval is P hat plus error. So you subtract the error on the left side and add the error on the last side. P hat is 0.35. So you have 0.35 plus error of 0.066. Then you gotta put the other stuff. It's less than the P. Less than P, which is the proportion we are trying to estimate, and less than 0.35 plus 0.066. That will give us the confidence interval. Okay. So we can now go to the calculator and put these numbers in. We have our calculators, the decimals. Okay, so we have that 0.35, 0.35 minus error. Minus error of 0.066. And this will give us the answer 0.284. 0.284. Now we do the same thing, but add it this time. It gets the upper side, which is 0.416. So this 0.416, so you can go back and put this in our main workbook. Our main workbook, which is this one here. If you add these two from what we have from the calculator, if you add this, if you subtract these two, it gets 0.284. Okay, less than P. Okay, less than P. Let me just put this side so that I can just change numbers. less than P. I'll put right here. If you add this side, these two sides, what we got from the calculator was 0.416. This is the same as saying 28.4% to 41.6%. So that's how we conclude it. Conclusion. When you want to write the conclusion, always look at the equation. That will give you a hint. I want to write, say, remember I say that in a random sample of 200 investment advisors, 70 recommended IT stocks, give 95% confidence interval for the true proportion. So you can say that between the percent what we have between 28.4% to 41.6% of IT professionals, investment advisors recommended IT stocks. So we can say with 95% confidence that between 28.4% to 41.6% of the investment advisors recommended IT stocks. So, any question on this? Hello, class. Any question?
No.
Good. Excellent. So sometimes they may not give you this, not the 70 and the ends n and x. Instead, they'll give you the proportion for a percentage value or the proportion value that they have, and they want you to use that to estimate the true proportion. Like if you look at this question here, this one here, what is it? Okay, look at this number 15. It says the other two, this 1 and 2, you can try them as a practice at home. Look at this one here. It says a survey of 200,000 boats owners found that 12% of the pleasure boats were named Serenity. See, they didn't give you, they just give you the percentage value. And they say find the 95% confidence interval of the true proportion of boats named Serenity. In that case, like I said, they already gave you the value of the for P hat, which is 12%. How many boats were selected? They didn't give us. Okay. Oh yeah, they did. They said 200,000. So our N is 200,000. I'll change this to small n. Okay. So our P hat. Okay. P hat will be our P hat. P. I'm gonna put the hat myself. So P hat gonna be like this. Okay. Equals 12%, which is you have 0.12, and Q hat. Okay. Q hat. Q with the little hat. Okay, I'm gonna put it right here. Okay. Equals 1 minus P hat. P with a little hat. You know, 1 minus P hat. Okay. Okay. Okay, 1 minus P hat, which is 1 minus 0.12. So I'm gonna take you to the place, okay, the calculator. Okay, my calculator will be somewhere here. So you got 1 minus 0.12 plus 0.88. So P hat is 0.12, Q hat is 0.88. We'll have a sample size. Okay. Have our sample size to be 200,000 nuts of pleasure boats. So that means our 0.88. Now, our N is 200,000. So next thing is to get our Z alpha over 2, Z alpha over 2. So I'm going to just go copy the formula from here. Now, it says in the question 95%, and we're lucky we used it before. So it's going to be right here, same thing, 1.96. If it's 90%, then you're going to look for it on the table. Remember, I told you there's a table where they are listed. If they're not there, you can always, calculate them using the P over 200, the way I showed you last week in class. Now, with this, we are ready to calculate the error margin. Here's the formula we use for error margin. Same formula we use error. So I'm going to paste this in our other workbook so that we can make an estimate, of it. Okay. Get our error margin. So I'm going to move this. 1.96 is good. Here we're going to have 0.12 times, sorry, okay, times 0.88 or 200,000. So they have 200 pleasure boats owners. So placing this into calculator, 1.96 times 0.12 times 0.88 or 200,000. Let's see what it will give us from the calculator. Have this. So I'm going to clear this. 1.96, 0.96 times. Okay, we have this square root of. Okay. Excuse me. We have 0.12. Okay, times. We got 0.88. Okay, close this. Divided by 200,000. Okay. Right. It was 0.00142. So just 0.001. 0.001. So that means that the error margin is 0.001. Very small. With this, we can now estimate the confidence interval for the true proportion. Take it to the 0.001. So I'm going to copy this, paste it in our main workbook. Okay. So we're seeing this. Okay, good. Copy that. Paste it right here. So that the 95% confidence interval is now oh, sorry, we are here. So I'm going to paste it here, not there. Paste it right there. So that's the 95% confidence interval. 95% confidence interval becomes this. You subtract the error on the left side and you add it on the right side. So is p hat on error. Let me take it. Let me bring it from where we have it before. P hat minus error. I'll copy from here. So then change the numbers to reflect our own numbers. So it's right here. P hat error. Our p hat is 0.12. Our error is 0.001 on left side. On right side, 0.12 plus 0.001. It give us this. And plug this in the calculator to give us the answers. You know. So 0.12 have 0.12. Clear this. So 0.12 minus error of 0.001 give me 0.119. 0.119, comma. I repeat it for the same number, but to put plus sign to get the upper side, 0.121. So we have confidence interval. Okay. Go put this in right here in our main workbook. So 0.119 less than P. Okay. And then 0.121. So we can now conclude this is like saying 11.9% and 12.1%, which is also the conclusion. Okay. Now, question was to find 95% confidence interval of the two proportional books named Serenity. You can say, or we are 95% confident between. This one is 11.9% to one is 12.1% of pleasure boats. Their names, okay. Serenity. See? And that's it. So when they give you the when they don't give you the X and N, you use the percentage that they gave you, which is this one, 12%, as your p hats. I arrive at this. Any question on this? Any question?
No.
Very good. Very good. Now we can look at the last example, which is the sample size computation for proportion. So what we do in that, just like we did in the mean, we're trying to estimate the minimum sample size we use for our study. So for proportion, we use this formula here: p hat times q hat times z alpha over 2 over error squared. So then you round up to the next whole number. You round your answer up to the next whole number. Let's do one example here, and that will conclude our confidence interval. Okay. Let's say a researcher wishes to estimate with 95% confidence the proportion of people who own home computer. A previous study showed that 40% of those interviewed had a home computer. Okay. And it says the researcher wishes to estimate to be accurate within 2% of true proportion. Find the minimum sample size. So solution. So first of all, they give us the p hats as 40%. So let me move this down so we can our result p hats, p with the hat Okay, P hat. And they say that it is, okay, it is 40%, which is 0.04. Now, Q hat, Q with a hat, okay, is always 1 minus P, 1 minus P hat, P with a hat, okay? And that gives us equals, oh, this is 0.4, I don't, 0.0 for issue, 0.4, 0.40, 0.4, but 40% is 0.4. So 1 minus 0.4, which is 0.6. Now, another thing we need is the Z half over 2. Z half over 2. Now, it said 95%. So we have it already in this example here for Z half over 2. So 95%, we have it here as 1.96. Otherwise, if it doesn't give you the value, you go to the table and find it, or you estimate it using the formula I gave you last week. So, but here we have it already, 1.96. With this, we are able to estimate the minimum sample size using this formula here. Error margin, this is the formula right here. Let me paste it here. Now, but we still need the error. It is given in the question. He says that the researcher wishes to be accurate within 2%. So our error is 2%. 2%, which is 0.02. Now, plugging all this into this formula, we have our minimum sample size. Let me write this down, then we'll plug them in. It's gonna be P hat times Q hat time, and times the Z half over 2, which is the critical value over error squared. So let's go and put this in our main workbook, and then we can now estimate our minimum sample size. So I'm gonna go there and put it right there. Okay. Sample size, minimum sample size, I'm gonna make this bigger. Make it 16, maybe 18. So you're gonna be equals P hat is 0.4. Okay, I'm gonna bring this down so I can have room for computation. Okay, maximize this. So times Q hat of 0.6. Okay, times we need this. Let's put this. Also need some of this. We need this. So you have 1.96 over 0.02, and that would raise to the power 2 equal. So let's put this. I want to make it smaller so that it doesn't take all the whole space. Okay, make it 16 so it doesn't take all the whole space. Now go to the calculator and put this in. Go to the calculator and put this in the calculator. And the calculator is right here. So clear this, move this up. So we got 0.4, 0.4, okay, times 0.6, okay, times, we have 1.96, 0.96 divided by the error of 0.02, okay, squared. You get 2304.96. 2304.96. So we can now go to our workbook. 2304.96. Okay, which will be squared. I mean, that's the answer right there. So we're going to the notebook. Okay, and put them in. But before that, I need to copy it first. I forgot to copy it. Let me copy it first. So copy this, go to our main workbook, and then paste it there. So and now based on our answer, we can now determine the number of the sample they need. So that means 2304.96. So that means this was like find the minimum sample size. So we round it up to next whole number, always to next whole number. So minimum sample size become 2305 samples. Any question? Any question on this?
No.
So we'll be time. We have only 2 minutes, so we can't achieve much in 2 minutes. So I'm gonna time us out. Wait for 10 minutes. Log back in. Let us finish up. Okay.
Okay.
All right.